Okay, students, so this is a recording for 4.5, linear and Newton's method. So the first definition is linearization. So if f is differentiable at x equal to a, then the approximation function, let's call it L of x, okay? So L of x is the approximation function, okay? Or approximating function. So L of x is the approximation function equals f of a, okay, so that's a y output for a, plus f prime of a, that means that's the slope at a, times x minus a, is the linearization of function f at a. So what this really means is the approximation of a function, okay, at a point, let's call it a, okay, where later you're going to learn that where a is really the center or the equilibrium point, okay. So we're trying to approximate the equilibrium point using a line. Now this definition seems like a brand new definition, okay, but as we go through this section, I want you to kind of connect this with something that we have already studied, okay. So again, this definition right here is the approximation function at x equals a, is called the linearization of f at a. So let's use that right away. For each of the following, please find part A, the linearization, which is called L of x, for the function f of x when x equals a, and B, how accurate is the approximation of this a, okay, the approximation at a plus 1 in comparison to the actual value, okay, so that's what we're going to do. And now this part it looks confusing just because there's a lot of new notations, not really difficult in terms of content, okay, just really notations are new. So first, let's talk about where a is. So letter A, it says a equals -4. Then we need to talk about, hey, what is this point right here, 0.1 or 0.1, what does that mean? Okay, so let's talk about that in just a second. So first, letter A said find the linearization, which is L of x. And L of x, I gave you the formula earlier, which is f of a plus f prime of a times the quantity of x minus a. And a equals to -4. So what I would need is, I would need f of a, which is the y value, right? We know a is 4. So a is -4, I need to find f of a. So let's plug it in. F of -4 is -4 squared is 16 plus 9, plus square root of 25, square root of 25 is 5. So your f of a is 5. So now I have the a value and f of a. So what I would need now is the f prime, okay? F prime of a, which is, I need to find the derivative. So here we go. F prime of x is 1/2 times x squared plus 9 to the power of -1/2. The chain rule says I need to multiply by 2x. Let's make that a little prettier. So let's see. I think the 2 and the 2's here will cancel. So now on the top, I would just have an x over square root of x squared. So square root of x squared plus 9, and this is f prime of x. I need to evaluate this at x equals to -4, okay? So that's -4 on the top. And again, we did this already, so on the bottom is 5, okay? So this is f prime at 4. So we're just going to put it together in our equation, okay? So L of x is the approximation, okay, is, ready, f of a, which is 5, plus the slope, f prime of a, which is the slope, is negative 4 over 5, times x minus a was negative 4. I'm just going to try to make this really pretty, so I'm going to go distribute this out. 5 minus 4 over 5x. 2 negative will make it a positive. Oops, I meant to write 4 right there. Okay. So when you distribute that, I'm going to get a negative 16 over 5. I'm going to try to combine like terms, like those two can go together. So L of x is negative 4 over 5x. I'm going to change the 5 into 25 over 25, so that's 25 minus 16. That's going to be positive 9 over 5. This is my final answer. Okay, so this is the linearization, okay, which is the approximation of the function at a value a equals to negative 4. Now, part B says, how accurate is this information? Okay, so what does that mean? I need to find out. Well, what if now it wants you to plug in L of a plus 0.1. You already found L of x, so your a is negative 4 plus 0.1. So that's what I need to plug in. Okay, so L of negative 4 plus 0.1 is a negative 3.9. Let's plug it in. Let's see. Negative 4 over 5 times negative 3.9 plus 9 over 5. I'm just going to kind of use my calculator. Is that okay with you? So I'm going to use my calculator, and I hope my calculator is giving me the right answer. This comes out to be 4.92. Okay, so the linearization is telling us that, okay, that near x equals to negative 4. Near x equals to negative 4. We have 4.92. Let's plug this in to the actual function, okay, which is f function of negative 4 plus 0.1, which is f function was square root. Okay, so square root, and again, that's a negative 3.9 square plus 9. I definitely would need some calculator help here. So the y value at near negative 4 is 4.9203. So I want to know how close the approximation to the actual value. I'm just going to do an absolute value of subtraction. So 4.92, so take away 4.9203. It's an absolute value, so that means you can put it first or bottom, is really up to you. Okay, so it's going to be a small number, 0.000368, or you can say that's so small that's about 10 to the negative 3. Okay, so I would accept either way. The difference is, okay, the actual value and the approximation. Can you see the difference isn't really big enough for me to worry? And this method is really saying that, hey, this is an easier function. So technically you can put in the value right at negative 4 and get an answer. But there are some functions in real life application that it's just really difficult. Okay, it's just too difficult to plug in, or you can't even find the function itself. So it's just easier to find a line and then approximate near it. Okay. Okay, let's do the same thing, but let's do it with letter B. So on letter B, first it says find the linearization, so which is L of x. By definition, it's f of a plus f prime of a. And I want you to, again, keep in mind how this is related to something we already studied. I'm not going to say it, okay, but hopefully you are kind of making the connection, like, oh my gosh, isn't this? And then hopefully you can tell me in class some point. So let's find out f of a. A is 0 in this problem, so a is 0. So f of a, which is really f of 0. Oh, I love 0. ln of 0 plus 1, which is ln of 1, which is really, I love this number, 0. Okay, so right now you have a point 0 comma 0. I need to do the derivative. F prime of x is, the derivative of natural log is 1 over x plus 1. Technically, you do need to do the u times the chain rule, but the derivative of x plus 1 is just 1, so I don't have to worry about that. Let's evaluate at x equals to 0. Okay, so that will give me 1. So f prime at x equals 0 is 1. Now I just have to find L of x. So L of x is f of a, which was 0, plus f prime of a is 1 times x minus 0. So class, L of x comes out to be just x. Okay, so this line is going to give us the same approximation at a equals to 0 as if I were to plug in 0 for the original function. Now part B, let's test it out to see if it's true. Okay, let's plug in 0a plus 0.1. Our a value for this problem is 0, so 0 plus 0.1, which is really L of 0.1. When I plug it in, L of x is just going to be x, so it's just going to be 0.1. So this one isn't that difficult to work out. Same thing, f of a plus 0.1. Again, a is 0, so this is technically the same thing as 0.1 for f. Your f function is natural log of x plus 1, which I would definitely, that's my alarm. Okay. Now I'm just going to plug in natural log of 0 plus 0.1 plus 1, which now I would need to use my awesome trustworthy calculator. Okay. It spits out a number, 0.09531, and so on and so on and so on. Okay. So if you look at this, I want to know how close to the real value this is. Okay, so this right here is a real value. Okay, so approximating, so I'm going to do an absolute value to see the difference. So 0.1 minus 0.09531. Okay, so when I take this, I hit a really small number. Okay, like 0.00468 dot 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 dot. So as you can see, this is the same thing. It's so small. It's like, you know, 1 over. It's like less than 1 over 100. Okay, so I would take this as a difference. So it's a small difference in which, if you can, okay. So the higher math, the higher you go, the more ways you're gonna find to do to solve the same problem, okay? So what this is, I'm giving you another tool for your belt so you can solve something that you have already known how to solve, okay? And this is the end of this note.